let's go to page 112, okay, page 112, and this is lesson 2.6. This lesson is about to learn about how to prove statements about segments and angles. Okay, so let's go over what is a proof. Okay, a proof is a logical argument that shows a statement is true. There are several formats for proofs. A two-column proof has number, statement, and corresponding reasons that show an argument in a logical order. Okay, so right over here you can see that there are two columns. So normally that's how you do a proof. It says in a two-column proof, each statement in the left-hand column is either giving information or the result of applying a known property or fact to statement already made. Each reason in the right-hand column, so over here you give you the statement and you have to give you the reason. Okay. Okay. Each reason in the right-hand column is the explanation for the corresponding statement. Okay, now the way to do proof is that you kind of have to know what to do. A lot of students get stuck because they don't know how to start. Okay, so when you're doing a proof, you always start with the giving. So over here is giving. So you're giving the angle 1. Measure of angle 1 is equal to measure of angle 3. And you can see the little marking right over here, it shows that. Okay? So that is giving. Then what you want to do is you have to look at what you want to prove. So if you want to prove that measure of angle EBA, so EBA, so this is giving, 1 and 3 are congruent, and you want to prove that this angle and this angle, they have the same measurement or congruent. Okay? So now you have to think about how you're going to get from angle 1 to this angle. Okay, so see, measure angle 1 is over here. Now notice they kind of try to trick you, they kind of flip things over. Okay, so that's something you also have to watch out for. Okay, so here's your measure angle 1, so it's giving, that's where you start. And you want to end up over here, measure of angle DBC. So you start with angle 1, and you want to end up right over here. So you have to think, okay, if you start with 1, you have to end up right over here. That means you have to add angle 2, right? So same thing over here. See, angle 3, that's what you have beginning, right? And you want to end up with EBA. So you get EBA. So you start with angle 3, you want to end up at EBA. It means you have to add angle 2. So before you kind of start jumping to, you kind of have to look at what is giving and where you're going, what you end up. And develop the strategy, okay, how are you going to get from here to here? How are you going to get from here to here? Okay, so you're going to go from here to here. That means you have to add angle 2. And you have angle 3, and you want to end up right over here, means you have to add angle 2, right? So again, so you kind of develop your strategy first. So once you do that, now you can go and start, right? So again, so first, you start with measure angle 1 equal to measure angle 3, right? That's giving. Okay, the reason for that's giving. So again, everything you put down, you have to have a valid reason. You can just put down random things. Okay? And we already mentioned that to get from angle 3 to angle EBA, you have to add angle 2, right? So that's what we're going to do, right? Again, so you kind of have to plan ahead before you just jump into it. So EBA equal to angle 2 plus angle 3, right? Measure of angle 2 plus measure of angle 3. Okay, and that's angle addition. Okay, angle addition is, you have one part plus another part equal to the whole thing, right? And you do the same thing. Okay, or actually over here you can't do substitution. Okay, if I were to do it, I would probably do this one and this one at the same time. I probably do the angle addition at the same time, and then I do the substitution afterward. Okay, but the order can be switched. That's fine. So over here, they did a substitution right away because measure angle 1 is equal to measure angle 3, right? So see 3 and 1 are equal. So you substitute 1 into the 3. So again, 3 and 1 are equal, so they're interchangeable. Okay. Then from here, you also can see that measure angle 1 plus angle 2 equal to CBD. See that, or DBC, right? So same thing, angle addition partially. Then after that, you do the substitution again. See, because measure angle 1 plus measure angle 2, see they are same, right? So since they are equal, that means interchangeable. So you replace this over here with this. Okay, so this one you can use a transitive or you can use substitution. Either one is acceptable. Okay, if you use substitution, that's fine. So there's more than one way to do this. Okay, this is just one of the way. Okay, so now so you're going to do exactly the same thing with the segment. So you can just do it on your own. Okay, you can just follow. This is additional practice. You can do it. Okay, just follow the same step. Okay, now let's go to page 113. Okay, theorem. The reasons used in the proof can include definitions, properties, postulates, and theorems. A theorem is a statement that can be proven. Once you have proven a theorem, you can use a theorem as a reason in other proofs. Okay, so here's a theorem. Okay, congruence of the segment. So reflexive means something equal to itself or something congruent to itself. So segment AB is congruent to segment AB. So in other words, anything equal to itself. Okay, so symmetric property. So if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. So again, you just flip it over. Transitive, it involves three items. So if segment AB congruent to segment CD and segment CD congruent to segment EF, then you can just link it together, okay, just like dominoes, right? And then segment AB is congruent to segment EF. Okay. And do exactly the same thing. This is for segment and this is for angle. It's exactly the same thing, right? So reflexive property for any angle A is congruent to angle A, right? Any angle is congruent to itself. And over here, if it is a symmetric, means you can flip things over, right? So angle A congruent to angle B, then angle B congruent to angle A. So again, these are kind of common sense. And transitive, again, there are three items involved. So if angle A congruent to angle B and angle B congruent to angle C, then angle A congruent to angle C, right? Just transitive means you link them together. Okay. Okay, now let's go ahead and do example 2. Okay, name the properties illustrated by the statement. Okay, if angle R is congruent to angle T and angle T congruent to angle P, then angle R is congruent to angle P. So this is transitive. Just like again, so you got first equal to the second and second equal to the third item, then first would be equal to the third item, right? So that's transitive property of angle congruence. Okay, now this is like if you want to be very detailed, but if you just say transitive property, that's fine, that's acceptable. Okay, the next one, if you have a segment NK congruent to segment BD, then segment BD is congruent to segment NK. So this is the things flipped over. So this is symmetric property. Okay. Okay, let's go to example 3. Okay, so on page 114, example 3. Use properties of equality. So it says, prove this property of midpoint. If you know M is a midpoint of segment AB, prove that AB is 2 times AM and AM is 1/2 of AB. So given M is a midpoint of AB, and you want to prove that AB is equal to 2 times AM, and B, AM equal to 1/2 AB. So you remember when you're doing a proof, right? You always want to start, easier things is you always start with giving. So M is a midpoint, so that's giving, okay? Now, because this is a midpoint, so segment AM will congruent to segment MB, okay? That's a definition of midpoint. Okay? Again, midpoint will divide the segment into 2 congruent segments. Okay, so that's a definition of midpoint. And so if the segments are congruent, their length would be equal. Okay, so now, notice the difference between the two. Congruence deal with pictures, okay? Equal deal with numbers. So AM talking about the length of the AM, and this MB means the length of that. So the definition of a congruent segment, so if the segments are congruent, then they will have the same length. So that's what definition. Definition of congruent segment means if the segments are congruent, then their length will be equal. Okay. Now, next thing is, also that you got, because of you're dealing with length, right? So AM plus MB will equal to AB. So that's the segment addition partial. So the first part plus the second part equal to the whole part. Okay. The next thing is, since they are equal, then you can substitute, right? See, the MB and AM are equal, so they're interchangeable. So you can change or substitute MB by the AM. So you can change MB into AM. Okay. So that's your substitution property. And after that, you can add, okay? So AM plus AM equal to 2AM. Okay, over here it says distributive property. If you use addition property, that would be fine too, because your AM plus AM equal to 2AM. So if you have addition property, that's also acceptable. Okay. The next thing is, so this proves that first part. Now to do the second part, from here to here, divide both sides by 2. Okay, from here divide both sides by 2, you get that. Okay, and that is your division property. Okay, and that's your proof the second part. Okay. Okay, let's go over the summary. Okay, writing a two-column proof. In a proof, you make one statement at a time until you reach the conclusion. Because you make statements based on fact, you are using deductive reasoning. Usually, the first statement and reason pair you write is giving information. Again, not always, but almost, you want to always do that, okay? So it's always, probably the best thing to do, just start with giving, okay? But just be aware that you don't always have to do that. But usually, that's a common practice. Okay? And next thing is copy or draw diagram and label giving information to help develop proofs. So again, whatever is giving, like this, so giving angle 1 is congruent to angle 2. So you draw that and you put a little arc over here to indicate they are congruent. And so this is giving, and this is proof that angle 2 is congruent to angle 1. Okay. So over here, okay, so you can start with giving. So angle 1 is congruent to angle 2. That's giving. And because something are congruent means that measurement would be the same. So measurement of angle 1 equal to measure angle 2. So again, it says statements based on fact that you know, or conclusion from deductive reasoning. So deductive reasoning is you have to use the fact. Okay, you cannot just assume and using the pattern. Okay, so this is definition of congruent angles. Again, definition of congruent angle means if angles are congruent, that means they have the same measurement. Okay, the next thing is you do the symmetric property of equality. So when two things are equal, you can flip it over. Okay, and then after that, because two angles have same measurement, means they are congruent. So that's a definition of congruent angles. Okay. So again, so over here you can use definition, postulates, or proven theorems that allow you to state the corresponding statements. And okay, also remember to give a reason for not just the last statement, but for every statement you have to give a reason. Okay. And the number of statements will vary. Depends on the proof. Sometimes the proof can only few steps. Sometimes can have a lot of steps. Okay. Okay. Let's go to page 115 and example 4. Solve a multi-step problem. Okay. So shopping mall. So walking down a hallway at the mall, you notice the music store is halfway between the food court and the shoe store. Okay, so again, so you see over here, so you start to draw pictures. So over here, so music store is halfway between the food court and the shoe store. So sometimes you can just go and draw the picture, and when you have additional information, and if you realize your drawing is not correct, then you just have to readjust. Okay, so you kind of just start with something and adjust as you go. It says the shoe store is halfway between the music store and the bookstore. Prove that the distance between the entrance of the food court and the music store is same, so the distance between the entrance of the food court and the music store is same as the distance between the entrance of the shoe store and the bookstore. So basically, you want to prove that this is equal to that. Okay? Okay, so you can first you draw and label a diagram, then after that, you draw a separate diagram to show the mathematical relations. Okay, so again, so B is a halfway in between, right? So that means AB is congruent to BC. And the second picture, that BC is congruent to CD. Okay, okay. So step 3, state what is given and what is to be proved for the situation, then write a proof. So given B is a midpoint of AC, so B is midpoint of AC, and also C is a midpoint of BD. And you want to prove that AB equal to CD. Okay, so that's what you want to prove. Okay. Again, you start with a given. So B is a midpoint of AC and C is a midpoint of BD. So you have to think, okay, why do they give you that? Okay, the reason they give you that so that if this is when they give you the midpoint, that means what? That's your clue. You have to use a midpoint definition, midpoint or midpoint theorem or something how to do with midpoint. Okay, so over here, since B is a midpoint of AC, that means AB is congruent to BC. So AB is congruent to BC. That's a definition of midpoint. And same thing, since C is a midpoint, so BC is congruent to CD. Okay, so that again, that's definition of midpoint. Okay. Okay. Now next thing is, if AB is congruent to BC and BC is congruent to CD, okay, so there are 3 things involved, right? So that means AB is congruent to CD. That's your transitive property. Okay, so first item equal to second item, and second item equal to third item. Okay, therefore first equal to third, right? That's what it is. Okay, then after that, since they are congruent, that means they have the same length. Okay, so that's a definition of congruent segments. Again, if the lengths are congruent, then length would be equal. Okay, the distance would be equal. So make sure you know the difference between congruent and equal. Okay, congruence how to do with like picture. Look at the picture. Whereas equal how to do with like length, the numbers. Okay.